Alrighty, it's time for some exciting stuff. So, a giveaway, you say? Well, what the heck? Why didn't you tell me? I did. You just gotta watch my stuff. So this is a little something I like to do occasionally, here and there. Like I said in the previous video, 15,000 Subarinos. That is pretty badass, folks. Real cool. But I wouldn't be here if it wasn't for you guys. So occasionally, I like to help y'all out, be generous, and show all that love, because holy crap, did you guys show love. I was not ready at all for the amount of comments and just overall just holy crap that I got from this. What are we at, like 250 some comments? 252. That is probably like nearly one of the highest commenting videos ever. And all this came within 1 to maybe 2 days. Oh man, it gave me a glimpse into other channels. I don't know how the heck people do it. You know, like Bleep and Jeep. How many subs does this guy have? He's probably over 200k at least. I don't know how he keeps up with all the comments he gets every single day. It drove me crazy. But, oh my god. You guys, I can't. It was just, I was not prepared for all the encouragement. You know, that's really cool. The content that I put together has helped you guys, you know, with your confidence to work on stuff and just give you an idea. And you like how real it is and everything. And you know, I read every single comment. I promise you. And yeah. I appreciate it, guys. Seriously, that you blew me away. I wasn't ready for it, so thank you. It definitely gave me an insight into what you guys like about the channel, and I'm going to keep doing that. We're going to stay real, and I'm going to keep showing you the ups, downs, and everything in between, so very cool. But anyway, giveaway you say, huh? You want some stuff? I get some stuff. So, this is a little trick I like to play. Is somewhere hidden within a video, I will, you know, announce a giveaway. I won't make it very easy to find. You know, it'll be deep in there. You gotta watch, you gotta enjoy it. It's gotta be natural. And you know, the reason why I do this is because I want to reward the people that actually watch the videos. You know, I appreciate all the subscribers I got, but you know, the people that actually watch every week and comment and stuff like that, I think that's awesome. So, yeah, if we came somewhere all up in around Hero, saw my wonderful goofy face, and we were talking about giveaways and things. So it is time for those giveaways. Yes, that man. So I want to make this a little interesting and make a Arduino project. So we're going to use an REM to pick the winner. So this is how it's going to work. I went through and I asked people to comment what you liked about the channel or what your favorite video was or something like that. And I went through and picked everyone that looked like a good comment, something that I think was deserving of a winner. You know, there had to be a minimum amount of effort and stuff like that. There were some things I was looking for. And we've got ourselves the list and we're checking it twice. Whoa, so we've got plenty of contestants. So we have 66 total contestants. Some people have some weight, some people don't. I'm just going off the comment, like, you know, how deep into those heartstrings did you really pluck, you know, because I do appreciate the effort and I will reward it, you know. So everyone got a chance, but some, you know, get some bonus points to show your appreciation. You know, I will reward effort. So what we're going to do is we're going to make a program with Arduino. And we're going to ask the REM to pick. So basically it's going to cycle the numbers 1 billion times a second, and I am going to push the button to pick the winner. So it is kind of random, but it's random from yours truly. So if you are interested in learning how to code, then check the end of this video. If not, then don't worry about it. Just check the winner and go about your merry way. Okay, so if we come over here, we can see everything that we just did. We can see our first line and our second line of text. And if we push any of these buttons, we're going to get a winner. Now, in order to know that your things are working, what you can do is serial stuff. But this video is getting kind of long. So here we go. You ready? We're going to push the button. Who is the winner? Drum roll, please. And the winner is number 55. Yes, you see? Okay. So now, so look at this list. I'm not going to change anything. All I'm going to do is move everyone out to their weights and figure out who number 55 in the list is, because you is the winner. 1 second. Okay, so I've come in here and I've separated everyone according to the number that I put. So first, just to go over, these are in order by when they came in. So the top is the first comment, the last is the last comment. And these numbers over here, I'm giving people some different weights. So don't be offended if, you see your number and you're like, what the heck? I went off a couple things. Is one, how much effort did you put into the comment? If it was just like a couple words or like a little tiny sentence, I probably didn't pick you. If you got a 1, it was like, okay, that's kind of nice. If it was 2, you pulled a little heartstrings, and I'm like, okay, that was, it's serious and some cool stuff, and yeah, I'll give you some points. And if it was a 3, then it was like, holy crap, that's pretty awesome. But anyway, if we come down, here's the whole list. And number 55 is Chaz Gordon. Chaz Gordon. Let's get in there. Mr. Chaz Gordon. You are number 55, sir. Congrats. Congrats. Alright, so let's go through here. Let's get these comments all loaded. You want to load anytime today, YouTube? That'd be great. Please and thank you. P's and Q's. Pile of crap and shoes. Come on.
If you shop on Amazon...
No. Okay, there we go. Anyway, command, fine, Chaz. Gordon, anything yet? Keep looking. Come on. Oh, there we go. Found him myself. It'd help if I could frickin' spelly. Okay. So Mr. Chaz, over here building a 95XJ, and his son needed some inspiration and guidance, came across my channel, was fascinated with the development of all that stuff. Cool, very cool. And, I was happy, he put some effort into it, and some cool stuff. I like to hear what everyone's doing. So thank you, Mr. Chaz. Message me on YouTube, and I'll get you hooked up with some goodies. Some goody johns. So let me know what you're interested in, and I'll set you up. Congratulations. You are winner. Okay, so again, big congrats, and to everyone else, thank you. Thank you so much. It really does mean a lot. I do appreciate it, no bullshit. That's the realest stuff I ever see. You really gave me a little motivation boost, and it does help, so every now and then, it's nice to get that little feedback of knowing that the stuff you do is useful. So I'm glad I'm helping the community and giving them the confidence to work on their shit boxes too. So that's awesome. So keep it up, and so will I. So yeah, congratulations again to Mr. Chaz, Mr. Chaz Gordon. YouTube me and I'll get y'all hooked up. And everyone else, again, seriously appreciate it. Till next time, see ya. Yeah, you thought we were done. It's a little fan service. You want to see my wiener? I've got 2. Pretty puppies. Alrighty then, so this is going to be a bit of some nerd stuff, maybe look into the future, and, just getting the feet wet, see what everyone thinks of this. I've been playing with the idea of maybe making some Arduino tutorials for a while, because I have learned a lot over the 2.5+ years that I've, learned it from the ground up. So I could share some basics and help people get into it the way I was looking for help that I couldn't find. And that's kind of the videos I do, is I make videos that I wish I could have found when I started. So, today we are going to make a giveaway winner. So if you already saw the video, we're going to hopefully push a button and get ourselves a winner. So this is going to be a very simple project that's just going to teach you the ins and outs and the real basic stuff of how the Arduinos work and how to code. So, all up in this Excel John, we've got ourselves a bunch of entries. And the first thing to understand when you're coding is you need to figure out how to turn your data into numbers. All right, anything that you're trying to do, you need to convert it into a number to work with it. So that's the big thing, is trying to conceptualize objects, items, ideas, information, and put them into numbers somehow. So here we've got a list of people, and I've given everyone a weight of their possible winnitude factor. So basically, if it helps, once you start to learn how to code, you can get an idea. You can basically start to code in your head and form that basic idea of what you want. So when you can get to that point, you pretty much got that nerd mindset going on. But anyway, into Arduino we go. So this right here is going to be a new sketch. And just as a precursor, Arduino is a couple different things. This is an entire package. So we have the Arduino IDE, which you see here. This is how we do code and write the programs. But there's also hardware, Arduino hardware, that works with the program. So it's an all-included design. It's really easy to get into. It's really easy to code and understand, and it's all together and easy. And there's tons of tutorials and examples and stuff. And it's if you want to get into coding and basic stuff, not graphics or anything crazy like computer programs, you just want simple, simple stuff. Arduino. Absolutely 100% recommend. I love the crap out of it. So now then, on to the business. So our basic idea is going to be as followed. So first I'm going to do a comment. So here is the idea. All right, we've got a bunch of numbers. All right, so we've got numbers, and we want to turn these numbers. We want to randomly select from these numbers, but I don't feel like doing actual random. I want there to be some actual human involvement. So, because who actually likes real randomness? You know, there's nothing interesting or exciting. Oh, woohoo! It's random. It's great. No, I'd rather have some human interaction with this. So the way that we're going to do this is fairly simple. One of the big things of Arduino is you can make them go super fast. It's ridiculous how quick these things can run. 16 megahertz, and with the teensies, they go up to like 96, 120 megahertz. Dude, these things can fly. So we're going to make a very basic number counting program, and it'll interface with an LCD screen and some buttons. So we'll do like this. All right, so we will increment, and we will wait for a button, and then we will display on an LCD. So that's pretty much it. It's really, really basic. A number counter, a button input, and an LCD. So let's get started, shall we? All up in here, we've got two different things, our setup and our loop. For this program, since it's going to be really simple, we actually don't need the loop. The loop will run continuously over and over again, but we really don't need that. We only need a one and done, and we can use some interesting coding logic to get that done. So anyway, so first we have to count up how many we have, because that will give us an idea of how big our variable needs to be. So I believe we can do, we can just do count. Yes. No, we want the sum. Sorry. Sum, right? Yeah. Okay, so we've got 66 entries here to deal with, and we can fit that in a byte. So, yeah, the big thing about efficient coding is learning what you can and can't fit into variables. So you're turning everything into numbers, and you are also trying to figure out how efficient you can make this. You know, what is the smallest box you can put these numbers in? So that's what a variable is. It holds the number, and you have to set the size. So we will declare our variable here. We will go byte, because byte is the smallest. It can go from 0 to 255. 66 fits in there. We don't have negative numbers, so we're good. So we will do byte. What do you want to call that? We'll call that winner count. Winner counter. And I'll put that guy at the end. You can declare this as 0 if you want. It's not really necessary. It'll, stuff and things. So this is going to hold our stuff. So what you can see here is we just declared our variable. We called it a byte. So that is what we're setting it, and we're setting it equal to 0. So this is the initialization. It is initialized initially as 0, and this is what's called a comment. These double stripes are not any code. This is just for people to easier read, and it is a huge help. When you start coding, comment everything you do. Super important, because when you look at this, you know, oh, what was this thing I did 5 years ago? Let's look at the comments to find out. Super useful stuff. Comment your work. Okay, so we've got ourselves that. So let's work into this. So we are going to take our winner count, and what we can do is some shorthand. So we can do ++ winner count, and what this will do is increment the variable. So that's real simple. This would make more sense in a loop because it'd go over and over again. So you run the sketch, and it'll add 1, and then the next loop it'll add another 1 and add another 1. Okay, great. So now we got stuff, and it's continuously moving, but eventually it's going to hit a dead end. So with Arduino, when it hits the dead end, say it hits 256, what that actually means is it's going back to 0. So it just kind of loops forever in that one direction. So that's kind of nice that we can use rollover to our advantage, but we don't have 255 entries. We want to make this smaller. So we are going to add some logic. So we're going to say if, and we're going to enclose this, if winner count is greater than 66, then we will come in here and say winner count is equal to 0. Yeah, well, guess we'll do 1. So that is the next part of the code. So this one right here, we'll start commenting, add 1, and this, reset if too high. Alright, so this is the basic thing so far. What does this look like? It'll just, you know, count over and over and over again. So that's cool, but we need to do some more useful things to it. So, like I said, this is going to be a little advanced for a beginner tutorial, but we'll just learn about it anyway. We're going to use what's called a while loop. So while, and I guess our while loop is going to be based off the button input. So while the button is low, which means it's off, keep doing this. And what that means is the things that are going to be enclosed in these curly braces, so we'll go down here and make some curlies. Go down here. Okay, so while this thing is true, do this. And what that means is the second the thing you put in here is false, then it will exit this while loop. So we'll go while button, we will call this something else. Say button input, I guess. While button input equals low. So what that means is it'll, when we get to this part of the code, it'll start here, it'll do this piece, and then when we get here, it'll go back to the top and check. Is button loop still low? Is button input still low? Yes? Okay, do it again. And it'll keep doing that over and over again until this is no longer true. So when button input is high, then stop. Okay, cool. But this button, we need to declare this whole thing to begin with. So we will use something else called bool, or you can spell it out as boolean if you want. And this will be boolean button input. Okay, and what you could do is, you know, false or low, whatever you want. And this will be the button input holder. So now we need to actually access this button. So the way that we do this, this will be a digital pin. So this is one of the things you can do with Arduino is you have analog or digital pins. So this one, we'll just use digital. So first we have to go into pin mode to declare this pin. So I guess before we get there, we actually need a pin as well. So we are going to use something called a const byte. And what this means is a byte that is constant. And the important part here is a constant byte cannot be changed by the program. This is important for things that you don't want to change. For instance, things like a pin. So constant byte button pin. And that will equal, I'll have to look and see which one it is. I actually have this written down. Let's go all the way up to here. Doodly doodly doo. Okay, our button pin is a 13. So the nice thing is you have to check and see with your Arduino which pin you're using. But on the Teensies, the analog pins are also digital capable, so that'll work just fine. So our constant byte button pin is equal to A13, or analog 13. This also has a digital reading. So if we wanted to, A13 is also equal to... Oh. Well, screw me sideways. A13 is not digital capable, so that is analog only. Okay, so we can't do this, but if it was digital, we can do that. But anyway, we can still leave this, but we won't have to screw with pin mode. But in case you did, I'll just show you how this works real quick. So we will say our button pin, wait, hold on, pin mode, right, input. Okay, so what this does is for digital pins only, you have to declare what the pin is going to be. So the first argument is going to be your actual pin. So when we go here, we're putting in a variable. And the code is going to come up here and look, what is button pin? Button pin is A13. So it'll say pin mode A13, and what is it? Is it an input? Is it an output? Is it an input pull-up? You have to learn more about what all the digital business is. But for now, just know that if you want it to be an input, you can do that. And if you're doing buttons, you'll want this to be a input pull-up. That'll activate an internal pull-up resistor to keep the line high. But that does change our logic. It inverts it, so this would actually have to be high, and when you push the button, it'll go low to ground. And again, topics for another video. But anyway, as we noticed, this is not a digital pin, so we can't do this. So instead, what we will do is go analog read A13. And what this will do is give us an analog reading. So for analog, it's more than digital. For this guy, it's going to be a value from 0 to 1023. So 0 is 0 volts, and 1023 is equal to your VDD on the chip. For Teensy, that's 3.3 volts. For most Arduinos, it's 5 volts. You can do conversions and stuff, but that's not super important here. So instead, we're going to take this guy. And the cool thing is we can drop this right in here. So what we're going to do is say, while analog read pin 13 is less than, let's say 5, just to keep it at a nice little threshold. So basically, while analog read is less than 5, keep doing this thing. So when we push a button, this will go high, and we'll be all good. All right, so that is the main component here. Is we have our button reader. Okay, so while button is not pushed, EX 0 volts, do this and loop forever. Okay, cool. So now we got the basics, but we want to interface with our LCD screen. So we are actually going to have to use something called a library. So for libraries, we can go into Tools, I think, or Sketch, include library, and we will want liquid crystal. Where's that L? Liquid crystal, bingo, bango. Okay, so if you notice up here, this will add ourselves an include, and what this is, include library. And what this allows us to do is basically people write functions and turn them into libraries, which makes it really easy to do complicated stuff. So you don't have to do any of the hard work. People have done things for you. All you need to do is figure out what the libraries can do and use them appropriately. So I know, for instance, in the liquid crystal library, the first thing you need to do when you want to talk to this, you go LCD, and we will do lcd.begin because we need to start the LCD. Now this argument or this, I don't know, function or whatever you want to call it, it takes 2 arguments. It needs to know the amount of characters in each row and each column. So this will be, I forget which one is first. It's 16 by 2. But let me check and see which way this goes. And you can always look this up. Just Google it or try to find the library and see what it all does. Okay, no. Okay, right here. See, LCD.begin 16.2. All right. So what this is doing is start LCD library, and it will be columns/rows. So it's 16 columns and 2 rows. All right, cool. But the problem is we need to preface this and tell it what pins are what. So when you hook up an LCD, there's tons of pins that have to go here, there, and everywhere. But I already have this laid out, so we will just copy this here as so. So up here, we'll just add that. I guess just for sanity's sake, we'll put this over here. Okay. Don't mind my terrible spelling. It gets better. Not. Okay, so we will just move that like there-ish. But you can get an idea. Again, this is stuff you can look up. When you're using an LCD, you can put it in 4-bit mode, 8-bit mode, SPI, but I haven't actually looked on how to do that yet in serial stuff. But this is the easiest. So here's the pins right here. We have a, I don't know if that's a reset pin. I don't think so. It's something else. It's some kind of state pin. But anyway, we got the RS pin. We have the enable pin. There's another pin that we just tie low. And then these are the 4 bits, 4, 5, 6, and 7. And we will just tell it every single pin that is being used. So you can see all these digital pins that we will be using for this. There. So just put in the pins that you use for each pin, and we're set. So now what this means is we included our library, we told the library what pins to use, and we told the library to start the screen. So now we can do screen things. Excellent. Alright, so look at that. This is starting to look like a program almost. So we've got our LCD.begin, but I think it'd be exciting if we actually put something on the screen. So next what we're going to do is first LCD set cursor. So what this does is tell the LCD where to start, and then the next will be what to print. So same as above, this one will be, it depends what we're going to write, but we could say 2.0. Actually, we can do that. And what this does is start at column 2, row 0. Now something weird that you're going to learn about in programming is a lot of times things are what's called 0 indexed. So things start at 0. So the first row is actually 0 and the second row is 1. Third row would be 2 and so on. It starts at 0 instead of 1. In programming, sometimes that can be useful, so it's something you may have to understand and learn. So now that we tell the cursor where to set, the next thing we can do is print. So we do lcd.print, and we will tell it what to print. Now we would like to print text, so we are going to put these little quotations, and this makes a little string for us. We're not even going to get involved in what a string is, because I don't even really know. But this is where we put our magical words. So this will be our text. So it'll be pick a winner. And then you're going to learn how to be lazy and just copy and paste. So now we will paste and we'll move down to the next row. And this will be push to draw. Okay, and we're just going to do some quick little math because I'd like to center this. Everything is left justified, so have fun with that. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14, 16, 2, that sounds about right, right? 16 minus 2, so we actually want 1. Alright, so for this one we'll start at column 1, and this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 16, 12, 4, 2. Alright, that is good. Good. Alright, so this is what we did. We started the screen, we set the cursor to the first row, print a thing, set the cursor to the second row, print a thing. Okay, so now we have initialized the screen and put the things on the screen. Now we move on to the while loop, which does the counting. Oh, naughty me, I didn't format this. Okay. Yeah, when you're counting, when you do these curly braces, it's good to tab everything in, so that way you can see kind of the chain of command and the flow. If you wanted to get technical, you could come over here and do this, but you don't need it. If there's only one row, then you don't need this. So just to keep things clean looking, I don't like that. But when you're first starting, it is good to make sure that you have everything set up appropriately. Okay, so now we have our while loop, which is waiting. Once we push the button, we're going to get a winner. So our winner count is going to be here. Now, we need to learn about scope a little bit. We declared our winner counter. Ooh, winner counter. Make sure we write that one right. Our winner counter is what's called a global variable. It is set up outside of the setup and the loop. So this is global. That means that anything with this exact name can see this particular variable. If you wanted a different scope, you can also do it in here. So you could do byte, example. And this example is only visible in setup. If you were to go to loop and ask for example, it would go, I don't know what you're talking about. And that can be very useful to make sure that you're not writing over things that shouldn't be written over. But that's for another time. Anyway, let's finish this up. So now we push our button, we get our winner, and we want to print the winner. So next we will do something called lcd.clear. And that doesn't require any arguments. So what this does is clear the screen so that we can print new stuff. If you don't clear the screen, anything that is remaining is just going to be there. So you could write over top of it, but it's going to be garbled unless you use spaces and print them. Ugh, it's a mess. So yeah, we're just going to go over here and we're going to copy this again. Again, learn to copy and paste. It's quick and easy and a lot less writing. So pick a winner, and this will be winner is, and this will be number I don't think that's all going to fit. Is that going to fit? I don't think so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Nope. And the winner is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, that's good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. But we're not done yet. So I'm going to teach you some other magic here. We're going to do a little number sign, and then we are going to copy this one more time, and we're going to use the actual variable. So we're going to learn, now we have this wonderful variable, how do we turn it into something useful? So we just want it to represent itself. So we're going to take winner count and just post it right in here. And that's it. So what this is going to do is this is going to be either a 1 or 2 digit. So let's check here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so 14, this will be a 1. All right, and that'll be it. So that's pretty much the basis. We're going to print a screen. We're going to count until a button is pressed, and then when it is pressed, we'll clear the screen and write some new stuff and show the winner. Now, if you'll notice, this code does not have any delays in it. That means that this will go as fast as it possibly can, which, might I add, is going to be ridiculously fast. So that is our main randomizer here, is this is going to go way faster than anyone could ever count or figure out. For instance, it takes approximately 50 to 60 milliseconds to push a button, for that button push to be registered, for you to push down and lift up. and that's clicking it as fast as I could possibly go, is about 60 milliseconds. To put that into perspective, this thing can do loops in the microseconds or maybe even nanoseconds. So this thing can loop through thousands of times, maybe not thousands, hundreds of times in the time that it takes a full button to press. So that's going to be our random is, when do you push the button is where it stops. So that's going to be how we do it. So now then, you should do this along the way, but first we're going to make sure we're on the right board. So we got Teensy 3.2, this is a download, Teensy Arduino, blah, blah, blah. And we have it port right here because we have it plugged in. So we will verify the sketch and make sure we didn't do any dumb stuff. So we got to save it. So this is going to be winner underscore selector. They don't let you do spaces, so okay. Save that, and then it'll verify. So we'll see a bunch of stuff in here. Okay, so you can see it just caught ourselves an issue because I'm dumb and can't spell. So you need to make sure it's a computer and it's only as smart as you are. So you gotta make sure it's all right. And again, goofed up. All right, let's check. Any more errors? Nope, it compiles. Okay, cool. So now what we do is upload, and that's gonna open this guy because it's part of Teensy. If you're doing Uno, none of this happens. So we'll just hit upload. It'll do some things. It'll compile, program, and boom. Now, I kind of goofed and forgot there is one more thing that I forgot, and that is that we need a backlight so we can see what the heck we're looking at. So, we actually can do some digital pin stuff. Yay! So we're going to go up here, and we're going to go const byte, green pin equals 25. So we will go up here, and we will go pin mode. And this is setting what the pin mode is. So pin 25, which is going to be our green pin, is an output. Okay. And the reason why we do this, why don't you just put 25, right? Like, wouldn't it just be easier to just write 25? Yeah, it would. But here's the problem. Imagine that this code is multiplied, copied all over the place. You've got pages, you've got, thousands of lines, tons of functions, and they all share stuff like this. You won't have to go through every single one, find out where the thing was, and update it. I wouldn't. What if you decide, I want 25 for something else. Let's, move LEDs somewhere else. Well, instead of doing that, you change it once here and say, okay, it's on pin 24. Now, all of these guys down here will all know, hey, use 24 instead. Super useful to do stuff like that. Work smarter, not harder. So anyway, we set the pin mode type. So now what we're going to do is a digital write. Digital write, if I could frickin' spell. Okay, and we're going to do green pin high. Okay, then there you go. If we wanted to do analog, this is an analog pin. We could do analog PWM. So what you would do is analog write, and you would do green pin, and let's say we want half brightness, so that would be 128, and that would be half brightness. So yeah, but that's only if the pin supports PWM. So you'll have to make sure and check that stuff. But that's a good way to dim LEDs digitally. But anyway, now we've got something. So we will upload that, and every time you upload, it verifies first. So it'll always catch an issue. So, now then, let's do it live and see what we got. Okay, so if we come over here, we can see everything that we just did. We can see our first line and our second line of text. And if we push any of these buttons, we're going to get a winner. Now, in order to know that your things are working, what you can do is serial stuff. So, here we go. You ready? We're going to push the button. Who is the winner? Drum roll, please. And the winner is number 55. Yes, you see? Okay, and just to show off, just to fully explainify that if you didn't think this was fair, I will show you how it's fair. So we will go into here, and we will do some stuff. So we will do something with the serial monitor, because there's no way in hell I'd be able to show this on the LCD quickly enough. So we will do serial.print. And what this does is it uses the built-in serial monitor in the Arduino And this chip can communicate to the computer and send stuff. So what we'll do is go like this and go like that, and this will serial print this number to the computer. But first we will have to initiate that. So we will have to do serial.begin to start it, and we'll have to set our baud rate. So we'll do something nice and fast, like 15 to 100. But we're not done yet. We still have to include the library so it'll actually work. So we will do hashtag include serial, but who's got time for that? Include serial library, where are you? Cereal, I'm hungry for my cereal. It's escaping me. It should just be, it's not software serial, it should just be serial. Yo, man. I'm gonna feel dumb if it's not a library. It's gotta be, right? Where is it? Crap. Oh, maybe not. Okay, maybe I'm just being dumb. Let's find out if it works. Oh, yeah, okay. So we don't need a library for that. That is built in, A+. So we're gonna upload that. Okay. Now, I'm gonna warn you that this is going full speed and it is gonna look like gibberish, but here are all the numbers. So just to prove to you that this is the way that it works, if we check, you can see it's counting from 1 all the way down to 66, and it's doing this a bazillion times a second. And you ready? I'm going to push the button, click, and you can see it just stopped at 25. So this is purely random, in a sense, completely controlled by me, and no way in heck I'd be able to number count that. So yeah, there's a thing. And if you are interested in going a little nerdier just to see how quick this goes, we'll do something a little different then. So we will go, let's make another variable real quick. We will call this unsigned long timer. And we will go like this. We will say timer equals, and this is going to be quick, so we're going to use micros, which counts the amount of microseconds that the thing has been on for. How do we do this? It'd be helpful if I could spell micros. Hello. Okay, so it will be micros minus previous time will be the actual time. So we're going to do some cheap stuff here. We're going to go, we'll just do a word, and this will be gap, and we'll call this previous time. Okay, so now we have that, and then we will serial print gap, and also we will go previous time is now equal to there's actually, what we can do is do plus equal micros. No. Well, yeah, plus equal gap. So what this is doing is, since we're not actually putting micros in its own little thing, this is kind of cheap. You could use this with more variables, but what we're doing is we're taking the time, the actual time, and subtracting the previous time to get the amount of time between each loop. And then afterwards, now that we have our gap, our previous time is now equal to itself plus gap. So plus equal really just means previous time plus gap equals previous time. So we're taking a thing and putting it back into a thing. So anyway, we will instead print out the gap. And let's see, does that work? It works. Okay, so now we will check this. And you can see that each loop is taking, 14 to 15, sometimes 16 microseconds to do that. So a microsecond is pretty friggin' fast, folks. But yeah, just know that this thing is going a lot of times. I said, wait. I think we can do something here. If we do 15 divided by however many friggin' secarunos are in here. How do we do this? Do divide it by this? Yeah, there we go. Okay, so power of negative e, so it'll be be 15. 1, 2, 3. 1, 2, 3. I think that's how we do that. So if I'm getting this right, this thing will happen 66,000 times a second. And the nice thing is, since we have 66 total, we can just do 66666 divided by 66. So this is actually going through the loop 1,000 times a second, if I'm getting that right. I might not, but you know, someone can do the math if you have to. But there you go. This thing changes 1,000 times a second. Like, it goes through 1,000 loops a second. So, yeah. I would have to say that's pretty fair. Okay. That's all for now. If you liked it, let me know what you like, what you don't like, what you'd like to see, what you'd like to change, and all that good stuff, and maybe we'll do this again sometime.